we have done written for the traversing the complete tree, but behind the scene would be using recursion. And that's why we use even recursion, because writing the code is very simple. It looks very simple, and it is very easy to understand too for anyone. So here we have made it. Here we have used a tail recursion, so we can even define it as tail recursion. Okay, why it is? Because in this function we are calling this function again here, our recursive function we are calling, but this is the last operation which we are doing. Okay, we are doing some operation here. You can see in the arguments I am doing some operation here. I am doing some multiplication, I am doing some subtraction, but this will happen in the argument, but in the last this function will be called. Okay, so this will happen means this, first of all, this n minus 1 will happen, this n multiplied by a will happen. After this, then this function will be called. So we can say in this particular case, the last operation which is happening is this function call, and that's what we wanted. And this benefit we will get, and we can utilize it. Even we have multiple optimizers which will help us to convert this code somehow in iteration. We have written our code in recursion, but we will not face any issue, but it would be somehow converted in iteration. Our CPU will think it is an iteration code, so it will not create that every time a new stack. We will not face this issue. Our code will be fast. It will run smoothly. We will not face any issue, as well as writing the code is also simple. Okay, we can't convert. We can't create each kind of use case into a tail recursion. That's not possible. But in most of the cases we can do. Where we can't do, so in that case we can't convert. But if we can do, then we can go ahead with. Okay, so we have done this. Now we have some optimizers, and now the compilers which support is like one of the compilers G++. I hope you have already tried this practical. I think I already have this command. So this is a compiler. Okay, G++. And now let's say if I wanted to run let's say my app1.cpp. This is my code where I am doing the factorial of, I think, 6 lakhs. I am doing the factorial of this, but this is a non-tail recursion. Okay, it is a non-tail recursion. You already know, and we know if it is a non-tail recursion, if you will do it, it is a very big amount. It will keep on creating stacks. So at one moment, it will throw a stack overflow issue. So now what we will do is we will compile our code with G++ compiler. We will write our file name, which is app1.cpp. This is our file name. We can also mention here the output which I want, because whenever it will be compiled, it will create a .exe file. If you don't mention, then it will create the exe file with the same name, app1.exe. But if you want, then you can mention. And here I am using some optimizers. How it is working, I will just show you. So even I am using some optimizers, but this code is not non-tail recursion, so it will not work. Let's see if it works or not. So I have compiled it. Now I wanted to run this myapp.exe, which I have created here. I will run this. So you will see I am doing the factorial of around 6 lakhs. I am doing here the factorial of 6 lakhs. I have created my all code and everything. I can call my function, and while running this particular code, even if you run this in any of the language or with any of the compiler, basically in C++, if you will try to run this with any of the compiler, you will face one issue. After some time it will try, but after some time it will fail, and it will throw you error. Like here you can see it has tried till here, means it is keep on doing n-1. It is keep on trying, but after this much it got failed. Why? Because of stack overflow. Okay, but if you don't want this kind of issues, then you can convert your code in tail recursion. So you can see this code, which app2.cpp, which I have, it is in tail recursion. Now in this case, behind the scene, we are using tail recursion. It will convert our code something like iteration. So now we will not face this kind of issue. It will not fail here. It will work till the last, and it will show us the output. I hope you would have already seen this practical. So now we are compiling this app2.cpp file. This is the same file which I have here, app2.cpp, which is a tail recursion. This was non-tail recursion, so it failed after 52,000 something. I think after 43,000 call it failed. Okay, but in this case it will not fail. Why? Because now I am again compiling it with the optimizers. Okay, these optimizers will help us to convert this into iteration, and we are going to use it. So again, I'm compiling it. So now this time I have compiled my add2.cpp. Again, I'm creating the same file. It would have got over right here. And now again, I will write this. I will run this myapp.exe, and let's see if this time it will run successfully. Okay, so this is how, and this is why this iterations or this recursion are so useful. Okay, so even today also we will be using this recursion to do the traversing in our complete tree. Okay, and even in future, when you would be learning about BST, binary search tree. Okay, so there you will see the use, because in binary search tree, whenever you were learning about it, you will have some tree. You will have some tree, something like this, with some data. Okay, 3, 4, 5, some data you will have. Now you will have to do the traversing. We have a couple of ways to do traversing. Okay, we will see all of them. Now, while doing this, while searching some data, we will have to first of all traverse everywhere, right? We have to traverse, like whether we have 2 here. Okay, so 5 is greater than 2, right? So it will be in the right side or whatever. How we are showing data that matters, we will see about it also. So traversing is very important. If you can do the traversing, then only you can go ahead and you can search the data, you can update the data, you can delete the data, because even if you have to delete something, right? So first of all, you should know where that data exists. You have to go there, you have to traverse there, and then you have to do it. So let's see if it is running. So you can see it is still running. Okay, now this time, as it is a tail recursion, it will not give us as such any issue. That Stack Overflow issue will not happen now. Okay, in the limited CPU, whatever I have in this particular system, it is working fine. Okay, so just a couple of changes we have done in our code, and we have used a compiler which support this optimizer. All the compilers don't support. Okay, the optimizer which will support, it will work. And even if it will work, then you will see in the last it will print success also when n will be equal to 0, and it will return, and it will exit from this complete recursive loop which I have created here. Okay, so this is also important, and this is how it works. So any issues on recursion? I think everything we have revised about recursion, how recursion works, how iteration work, why recursion is important, how it will be helping us to traverse our tree or our data structure, and how in future it will help us whenever we have to do searching or any kind of other stuffs, right? So there it will be helping us. Even the trees also we would be using. Okay, so we can in trees we have a couple of ways to traverse. What are these ways? We will see today. Okay, so I think we are almost there. I think for some time it will done. Yeah, it is going smooth. So here you can see it is doing the calculation. What calculation it is doing? So I have done 6 lakhs. Okay, so it looks like it is just printing the numbers, but it is not just printing the numbers. It is 6 lakhs, something like 1,100,000 lakhs, 6 lakhs. So it is doing 6 lakhs. Whatever calculation I have done, it will keep on multiplying till 1. You can think how it will be. Okay, and as n would be equal to 0, it will exist. It will keep on multiplying. What it is doing, it will keep on subtracting by 1. But means after 6 lakh minus 1, it would be 5,99,999, something like that. And then it will multiply that 6 lakhs with a. What would be a? By default, we will share the value of a as 1. Now after this, again we will run this. Again, the value will be keep on changing. Now this 6 lakh into 1 will come again as a, and then it will again do calculation. So you can see it is a very huge calculation. And even we can't store that data, because after multiplication, it would have a big value, a very big value. If you keep on multiplying this, we can't store this in a normal int, char, or double, or all of these kind of data type. Okay, so I'm not storing anywhere. You can see I'm not storing anywhere. I'm just printing the value of n. Okay, somewhere. I think here I'm printing the value of. But if you wanted to store this, you wanted to upload it to, let's say, somewhere in internet or whatever you want to do, then rest of the code you can write. Okay, but we have seen it can keep on working, and you can see till the last it have done it, we have got the success message. Why? Because of tail recursion. this was one of the things. So any queries, if you have, then you can ask. Otherwise, I think you will be now okay with recursion, and that we will use today. Okay, so I think Mimostat is here, so now we will start this.